Hello everyone, welcome back. This is the third lecture of week 5. We continue with logic coverage criteria. Before we move on, let's spend a few minutes trying to recap what we learned. We learned that a predicate, which is extracted typically from a conditional expression, can have several clauses. A clause is an individual atomic entity of a predicate that is free of and or not and other logical operators. Simplest coverage criteria for logic is to cover the predicate. Test requirement says make the whole predicate test true once, test false once. We realized that this could be inadequate to exercise each clause as being true or false, which is needed for testing. So we defined clause coverage, which said test each clause separately to be true once, false once. But then we realized this in the process need not make the predicate itself true and false. So it need not imply predicate coverage. We said that's not correct because the predicate should become true and false. So we said what is the simplest option? Test for all possible combinations of true false values for clauses across the entire truth table of the predicate. But then if there are n clauses for the predicate, we realize that there could be 2 power n combinations of true false values, and that gets to be expensive for large predicates. So ideally, we want a requirement that is midway between predicate coverage, clause coverage, and on the other end, all combinations coverage. That's when we started looking at active clause coverage. We said it's basically a way of considering one clause at a time to be active or major clause and let the minor clauses take values such that we explore the possibility of the major clause determining the predicate. That is, if I change the value of the major clause from true to false, that also changes the value of the predicate from true to false or from false to true. So this is called active clause coverage. We take one clause at a time in a predicate with several clauses as the major clause and test if we can achieve active clause coverage for that particular clause against the predicate. Based on the values that the minor clauses could take, there are 3 subcategories of active clause coverage, which is what is given here. Generalized, where there are no restrictions on what the minor clauses could take. We realize that this can be bad because it again will not satisfy predicate coverage. Then we said correlated, where minor clauses together take values such that the major clause for sure influences the predicate. That is, flipping the value of major clause from true to false does end up flip the truth or falsity of the predicate. The third one is restricted active clause coverage, where we restrict and say that a major clause will determine the predicate, possibly, and in this case, the minor clauses take the same value as when the major clause becomes true and as when the major clause becomes false. So this is what we saw till now. We saw 2 examples of how to achieve active clause coverage criteria. Moving on, we would like to consider the exact complementary thought. Just as we said that a major clause will determine a predicate, will become active and influence the truth or falsity of a predicate, we could think the extreme end and say that we consider inactive clause coverage criteria where the major clause does not affect the truth or falsity of the predicate. That is, same thing, a predicate has a set of clauses. We consider one clause at a time to be a major clause. For that clause considered as the major clause, we ensure that the minor clauses are such that the major clause does not determine P. Which means what? Major clause being true or false has no influence on the predicate being true or false. So that is what is given here. Inactive clause coverage, abbreviated as ICC. Consider a predicate small p. Consider clauses in the P. Let's say one clause in that predicate, CI, is the major clause. We choose minor clauses such that CI does not determine P. When CI does not determine P means what? the truth or falsity of Ci does not have has no influence on the truth or falsity of P, which means Ci could be true and P could be true, or Ci could be false and P could still be true, as the second row here says, or Ci could be true with P being false and Ci could be false with P being false. Please remember, inactive clause coverage says major clause does not determine P. So basically, four combinations exist. The major clause Ci could be true or false. And for each of these combinations, P could be true or false. We have no control. So this is your total set of test requirements. Ci as the major clause evaluates to true and false. P could be true in both cases. Ci as the major clause evaluates to true and false. P could be false in both the cases. This is inactive clause coverage criteria. Now you might wonder, what is the use of this? Why inactive clause coverage criteria? Active clause coverage made a lot of sense, but why inactive clause coverage? So here is a small example that will help you appreciate the presence of inactive clause coverage criteria. Let's say we are dealing with a set of requirements of a particular system. What is that system? That system is the control software of a shutdown system in a reactor. So let's say there is a reactor, maybe it's a reactor that generates power or atomic reactor, any kind of reactor, and it's controlled a lot by software. So such software is called control software. This software, along with other control actions, also has the capability to decide when to shut down the reactor. So the system that we are considering is the control software for shutting down system of a particular reactor. This software system, which is the control software, works in two modes of operation. One is a normal mode and the other is an override mode. Normal mode could be under the normal functioning of a reactor. When it's done with its job, maybe you shut it down. Or other could be override mode when there's a particular accident or an emergency, in which case also you go into the override mode and shut it down. So the system requirement specification is a particular valve that is used to maybe open or close, which is used to shut down the reactor. The status of that valve, the valve could be open or the valve could be closed, is relevant to the reset operation in normal mode, but not in override mode. So one way of shutting down is to not only shut down, but shut down in such a way that the whole system gets reset. For that, a particular valve is used, and that valve could be open or closed. One particular requirement, which is what is given in the second sub item here, says that the status of that valve is relevant to the reset operation if the system is working in normal mode, but it's not relevant to the reset operation if the system is working in override mode. That is, the reset operation should behave identically in override mode, irrespective of the state of the valve, irrespective of whether the valve is open or whether it's closed. This is the requirement. And we would like to specify this requirement as a logic coverage criteria, in particular as an inactive logic coverage criteria for this reactor. It says, this particular requirement says override mode does not affect the reset operation, right? Is this clear? Override mode does not affect the reset operation. So you understand now why we need ICC criteria, right? So it says that override mode should never influence whether reset happens or not. And it should behave identically when the valve is open and valve is closed. So this is the same as saying if override mode is a particular clause which represents a state of the system, then we make sure it does not affect the reset operation as per this specification. So override mode is an inactive clause as far as this specification criteria is concerned. We will see a few more examples as we go on. There could be several, like we saw for active clause coverage criteria, we could also do extensions, specifically detailing out what inactive clause coverage criteria is. So we detail it out for active clause coverage criteria. We had three types: general ACC, correlated ACC, restricted ACC. In the case of inactive clause coverage criteria, correlated ICC does not make sense. Why? Because we know that in the case of ICC, the major clause is inactive. It does not determine the predicate. In correlated active clause coverage criteria, the minor clauses would take values such that the major clause determines the predicate. Here, major clause does not determine the predicate. So, correlating the minor clauses values to major clause determining the predicate is not a well defined operation. So, we just generalize it to general ICC and restricted ICC. Correlated ICC is not a well defined operation. So, what is general inactive clause coverage? GICC. Take a predicate, take a particular clause in a predicate called major clause, choose minor clauses such that the predicate, the major clause does not determine the predicate. This is the same as this definition here. This first part is the same. Take a predicate, take a major clause, choose minor clauses such that the major clause does not determine the predicate. Because it does not determine, there are four optional requirements. Major clause can evaluate to true or false, with the predicate evaluating to true or false. So the values in general inactive clause coverage criteria, the values chosen for the minor clauses can vary. That is, it's general. We don't dictate or specify how the minor clauses take values. The same as for general active clause coverage criteria. Here also we say it can vary. There is no restriction or condition. The next is restricted inactive clause coverage, RICC. First part again stays the same. Take a predicate, take a major clause in the predicate, choose minor clauses such that the major clause CI does not determine the predicate. So test requirement has four parts. Now, because it is restricted inactive clause coverage criteria, we say in the case where the major clause evaluates to true, CI evaluates to true, that is parts 1 and 2 in this listing here, the minor clauses must be the same set of true false values. It's restricted. So, exactly like in restricted active clause coverage criteria, we do the same. And in the case where the major clause evaluates to false, then the minor clauses should evaluate to the same value. So, sorry, in the case where the predicate P evaluates to true, the minor clauses should be the same, that is cases 1 and 2. And in the case where the predicate P evaluates to false, which is cases 3 and 4, the minor clauses should all take the same value. So, this is our ICC. So, what do we have? We have inactive clause coverage criteria like this. Major clause does not determine the predicate. The test requirement has four options for major clause evaluating true to false and the predicate becoming true and false independent of the major clause. And the correlated ICC does not make sense. So we define general ICC where there are no conditions imposed on the values of the minor clauses. And we define restricted ICC where we say when the predicate becomes true, the minor clauses take the same value, and when the predicate becomes false, the minor clauses again take the same value. This is clear? So, this was about the kind of active clause and inactive clause coverage criteria that we can see. We are more or less done with looking at the exhaustive list of logical coverage criteria. Before I wind up this, it's important to understand how these kinds of logical requirements can become feasible or infeasible. Remember, when we did graph based testing, we talked about infeasible test requirements, especially related to prime paths and loops. And these infeasible test requirements being tested possibly by using side trips or detours. In the same way, logic coverage criteria can also become infeasible. We will see one expression. Sometimes restricted active clause coverage criteria can become infeasible. Sometimes it can be useful. Sometimes correlated active clause coverage criteria can become feasible or infeasible. All possible combinations can exist. We'll see one example about how infeasibility can arise in logic coverage criteria. So let's again take a particular system as an example and look at a particular valve in a system very similar to the reactor system. the valve can be open or closed, and the system can be in two different modes of operation: normal mode, or when the system is operational, and standby mode, maybe when the system is temporarily waiting or paused. So this particular valve can be open or closed, and a particular system can be in two modes, operational and standby. There are two requirements which are given as constraints on this system. First requirement, which is given here, says that the valve must be open when the system is operational and closed in all other modes. Is this clear? The valve must be open in the open state when the system is in operational mode, and the valve must be closed in all other modes. The second requirement, as the constraint says, a particular system mode cannot be operational and standby at the same time. That intuitively also makes sense, right? A system is either working or it's temporarily on standby. So a mode cannot be both together at the same time. So our requirement for testing is that we need to test for a certain action being taken only if the valve is closed and the system status is either operational or standby. Please keep this in your mind, because in the next slide, we're going to face it as a logical predicate. So our test requirement is a particular action is taken only if the valve is closed and the system status is either operational or standby. So let's assign a predicate to it. Valve is closed. That's this first part here. Valve is closed. System status is either operational or system status is standby. So I'm highlighting these logical connectives and or as I am deriving the predicate from a sentence like this. So it says valve, predicate P says valve is closed and system status is operational or system status is standby. So this I can write as A and B or C, where A I assign as a clause which says the status of the valve is closed, B which says that the status of the system is operational, C which says that the status of the system is standby. So the whole this test requirement, valve is closed and the system state is either operational or standby, can be written as a logical predicate like this: A and B or C. That either or actually, strictly speaking, makes it a exclusive or, but don't worry about that for now. Let's assume that it's an or. And remember, there were these two constraints also. The valve must be open in operational mode and closed in all other modes. And the mode cannot be operational and standby at the same time. So we would like to express those constraints also as logical predicates. First constraint says not A is logically equivalent to B. That is, the valve is not closed, which means the valve is open, means that the system is operational. That's exactly what this constraint is. The valve must be open in operational mode. So it says the valve is not closed is equivalent to the system being operational. Is this clear? Second condition says mode cannot be operational and standby at the same time. So how do you read the second predicate? It's not the case that the symbol is for negation. It's not the case that B and C hold together. B represents the system being operational, C represents the system being standby. So what I have done here, there was a particular system, there were two constraints on the system, and there was a test requirement on the system. So I have written the test requirement as a logical predicate by assigning clauses to the individual conditions, and I have written the two constraints also as logical predicates using the same clauses. While we are trying to write test cases to satisfy this predicate for our test requirement, we must ensure that the test case values also respect these two constraints. This is where infeasibility can arise. So let's go ahead and write. So as usual, remember when you're doing logic-based testing, it's useful to write out the truth table of the predicate. So this first part here is the truth table of this predicate. So there are three clauses A, B, and C. So 2 cubed possible rows of true false values. And this is the final value of the predicate A and B or C. Is this clear? So now let's look at the constraints. We had this constraint, not A equivalent to B and not of B and C. So if you see, row 1 violates both the constraints because A and B are true together. So not A will never be equivalent to B. And it says not of B and C. That's also not true because not of B and C will give me false. So first row violates both the constraints. So we can't use that for testing. It will not satisfy the test requirement of testing that condition. Similarly, second row violates condition 1. Again, A and B are true together. Seventh row and eighth row also violate constraint 1. A and B are false together. Remember, not A is equivalent to B. So their values can only be opposites of each other. So rows 3, 4, 5, and 6 satisfy constraint 1. That's not mentioned here. We mention only the violations. But if you see row 5, again violates constraint 2. What does constraint 2 say? Not of B and C. But here both B and C are true. So not of B and C would become false. So all these rows are ruled out in the sense that they cannot be used to satisfy our test requirement for this predicate. So we are left basically with rows 3, 4, and 6 because they are valid rows where the predicate becomes true or false and they don't violate any of the two constraints. That's what we are left with. Let's move ahead. Let's go back to the predicate. Let's say we want to do correlated active clause coverage on the predicate with A as the major clause. You remember this we had worked out in the last lecture, same example. We could choose any of the rows from 1, 2, and 3 and any of the rows from 5, 6, and 7. It's the same predicate. So if you see, it's okay because I could choose row 3 and row 6 and I'll be fine for correlated active clause coverage on the predicate because as per this slide, rows 3 and 6 don't violate any of the conditions. Both the conditions are met. But let's look at restricted active clause coverage criteria on the predicate P with A as the major clause. Remember, we had written down this row 1 paired with row 5, row 6 paired with row 2, and row 3 and 7 paired together. If you don't remember, request you to please look at the slides and the video of last week. We had worked out this last time. But now if you see, which are the possible combinations that we can choose for this requirement? There are only three possible rows that could possibly come for test cases: 3, 4, and 6. For RACC, we either need 1 and 5 together. That's ruled out because they violate one or more of the constraints. 2 and 6 together. That's again not possible. 3 is fine, but 7 again violates. None of these combinations of 1, 5, 2, 6, 3, 7 are a feasible test requirement for RACC because they end up violating one or more of the extra constraints that we had. So RACC is not feasible for A being the major clause for this predicate. Is this clear? Because there are additional constraints that make it infeasible. So how do you deal with infeasible test requirements? One is to conclude that it is infeasible and quietly let it go, ignore it. The other is consider other options. Like, for example, if RACC restricted active clause coverage criteria is infeasible, then consider correlated active clause coverage criteria. It's anyway more useful. Similarly, if correlated is infeasible, consider restricted active clause coverage criteria. Replace one with the other. This is similar to trying to do best effort touring with side trips or detours in graph based testing that we saw in earlier weeks. So, I hope this small example has helped you to understand how to deal with how possibly infeasible test requirements can occur because there could be additional requirements which we have to meet and one could contradict the other. And while dealing with infeasibility, we try to substitute one criteria for the other. So we've looked to summarize the various logical coverage criteria. This slide summarizes it for you. Let me start from the bottom end. We saw clause coverage, predicate coverage. Predicate coverage is the simplest form. Test the entire predicate true once, false once. Clause coverage exercises each clause to be true and false. We know that one doesn't imply the other. So we are not putting any arrow to indicate one of this clause coverage or predicate coverage subsuming the other criteria. That doesn't exist. On the other extreme, we saw combinatorial coverage, which is right on top of this table, which is like the most expressive logical coverage criteria because we test for the entire truth table. But it can get expensive and because of that infeasible. So we started looking at active clause coverage criteria, three variants: general, correlated, and restricted. All of them obviously subsumed by combinatorial coverage. They don't subsume each other because each one is different. We saw correlated active clause coverage criteria by its very definition subsumes predicate coverage, right? Then on the other side, we saw inactive clause coverage criteria. Only two variants here because major clause does not determine the predicate. Correlation doesn't make sense. So we have only two variants, restricted and general. This is the inactive clause coverage criteria. And we know that general inactive clause coverage criteria can subsume predicate because the predicate will become true and false. It can also subsume clause coverage because the clause will become true and false. So this is the summary slide of all the logical coverage criteria that we have seen, and read these arrows that connect these various boxes representing the coverage criteria as saying which one subsumes another one. Clause and predicate don't subsume each other, so there are no arrows. General active clause coverage subsumes cross coverage, so there is an arrow. Correlated active clause coverage subsumes predicate coverage, so there is an arrow between those two boxes. Combinatorial coverage subsumes everything, so there are arrows. And restricted active and inactive clause coverage don't subsume each other, so there are no arrows present. So I hope you understand this summary slide. This represents all the logical coverage criteria that we have seen. What we will do in the next lecture is how to actually practically work with active clause coverage criteria. Suppose I have a predicate that has several clauses. How do I take turns for each clause to be the major clause? And how will I find out values for the minor clauses such that the major clause determines the predicate? Is there an algorithm to do this? Can this process be automated? That's what we're going to see in the next lecture. So I'll stop here for now. I'll see you in the next lecture very soon. Thank you.